This brings us to our last application problem. It's quite a tricky one. Let's read through it. A rectangular garden is 30 feet by 40 feet. Part of the garden is removed in order to install a walkway of uniform width around it. The area of the new garden is 1/2 the area of the old garden. How wide is the walkway? Okay. This problem involves one rectangle inside of another rectangle. Can you see that? Can you visualize that? Let's draw a picture. We have a garden that's 30 feet by 40 feet. So let's make a garden 30 feet by 40 feet, okay? And we'll label the sides 40 feet, which is this side, by 30 feet, which is this side, okay? So we have our garden. Now, inside that garden, we're going to take part of it away, and we're going to put a walkway around the garden inside. So what's going to happen is we're going to put inside of it a path. And this path is going to be of uniform width all the way around. So if you can imagine, we have this garden. Okay, we'll just make it green for the garden, right? And we've taken out this part of the garden around it to put a path, a stone path if you like. And the thing about this path that goes around the garden is that it is the same distance on every side. We don't know how wide that is, but let's call it x feet. And we say it's x feet here, and it's x feet here, and x feet here, and x feet here, right? So this garden is now surrounded by a path x feet wide. Originally, before we took and put the walkway, the garden was 30 by 40, but now it's a smaller size, isn't it? In fact, the problem tells us that the area of this new garden here, the area inside here, is 1/2 the area of the old garden. So let me just put this 1/2 the area of the old garden, right? Alrighty, so let's figure this out first before we go any farther. What was the area of the old garden? The old garden, the original garden, was 30 by 40, right? And the area of a rectangle is the width times the length, or the height times the length. And so the area of the original garden was 30 times 40, or if you like, 1,200 square feet, right? That was the area of the original garden. Now, this new garden is said to have half that area. So what is half of 1,200? Well, half of 1,200 is 600. So that tells me that this area here that we're looking at is 600 square feet. Okay, so this area here inside is 600 square feet. So let's now focus on this garden right here, the new garden. All right. And let me designate it right here. And this garden here is what we're focusing on. And it has an area now, we've just discovered. The area is 600 square feet for this space here. Area is length times the width, or the width times the length. So what we need to do is come up with expressions for the length and the width of this particular new garden, right? What would that be? Let's see. Well, let's go back to our picture again. Let's focus first on this length here. Okay? Right here. The distance from here to here. We know the whole distance is 40. But we don't have 40. We have this far. How far is this right here? This right here is x, right? We've decided that border is going to be x units. And over here, this is also x, right? So if this is x units and this is x units, are you following me? And the whole thing is 40, then to get this piece in here that we want, this length right here, that is simply, see if this makes sense, that piece right there is 40 minus those two x's that made up the ends. Does that make sense? That would be an expression that represents the length of this rectangle. Perfect. So now let's talk about the height, going up and down, right? So going up and down, we want to focus right here on this distance, the height or the width of the rectangle. Let's dissect it again. We know that the entire piece here is 30. Do you see that? This far is x, again, because that's the width of our border. This far is x, because that's the width of the border. And so this extra piece in here, which is this distance here, is simply the entire length, 30. Take away those two x's, and that gives us our remainder part. So we would say that the height of this rectangle is 30 minus 2x. Oh, so hopefully this is all getting pieced together in your head. Do you see how this length here is 40 minus 2x? This length here is represented by the expression 30 minus 2x. We know what the area is, so we can write an equation down, right? We have the height of the rectangle times the length of the rectangle is equal to the area of the rectangle, correct? And so for our picture, we have 30 minus 2x being the height, 40 minus 2x being the length, and together that gives us this area, which we already calculated out to be 600, half of the original garden's area. And now we have our quadratic equation. We're going to multiply. So we use the distributive property to first FOIL through, right? We're going to take the 30 times each part, the 2x times each part. So let's go through and do that. 30 times 40 is 1200. 30 times 2x will give us minus 60x. The 2x times 40 will give us minus 80x. And then the negative 2x times negative 2x will give us plus 4x squared. And that's all equal to 600. This is a quadratic equation, an equation of degree 2. So we want to bring all the terms over to the left side and set it equal to 0. That's how we solve quadratic equations. So regrouping everything and simplifying and putting like terms together, we get 4x squared minus 140x. Bringing the 600 over gives us plus 1200 minus 600, which just equals 600. So we have this equation turns into 4x squared minus 140x plus 600 equals 0. Make sense? All right, our options for solving a quadratic equation: complete the square, quadratic formula, or factoring. I like to factor, so that's what we're going to do together. First, we're going to make this into a simpler equation because I observe that 4 divides into every single term in this equation. So I'm first going to divide every term in this equation by 4. And doing so will give us the following equation. It will give us x squared minus 35x, because 140 divided by 4 is 35, plus 150 equals 0. We now solve by factoring, looking for two numbers that multiply to 150 but add to negative 35. And this is a trinomial. And I think our two numbers are going to be, let's see, how about 30 and 5? Negative 30 times negative 5 gives us 150. And negative 5 plus negative 30 gives us negative 35. So x squared minus 35x plus 150 factors as x minus 5 times x minus 30. We now set each factor equal to 0, right? So that means x minus 5 is 0, or x is 5. And then x minus 30 is 0, or x is 30. Those are our two values that we have solved for x. Phew, we are just about done. We are being asked to solve for how wide is the walkway. That is, we're asked to find x, this distance, right? The width of the walkway, x. So x equals 5. Could this be 5 feet long? Well, absolutely, that would make sense. Because 5 feet is less than 40. If you have 5 on each end, it seems all good. So one possible answer is that the walkway is 5 feet long. How about this answer, 30? Would it make sense for this walkway here to be 30 feet? Oh, do you see that that doesn't make any sense at all? That this answer is extraneous? Why? Because if this was 30 feet long here and 30 feet long here, because remember the walkway is equal widths, that would give us a total right there of 60 feet without taking into account the garden. But this side here is only 30 feet to begin with. This number is too big, right? It's too big. That means it's an extraneous solution. Therefore, there's only one answer to our problem. The solution to our problem is that x equals 5, or in other words, the walkway is 5 feet wide. So that answer there completes our problem. These frame and border problems are a lot trickier than the ones in the previous topic. The key, I think, is to draw a picture and a diagram and label the sides. Once you do that, creating the equation becomes easy. And then solve, again by factoring, quadratic formula, or completing the square. Good luck and have fun with these.